All right, so we are going to do some thermostoichiometry. Now, this is asking for how much heat will be released, okay, which is asking for how many kilojoules of energy are released when 6.44 grams of sulfur reacts, okay? So, first thing we would have to do is balance the equation, okay? So, in this situation, it's already balanced, so we don't have to worry about that. Next, we are going to start this out just as a regular stoichiometry problem. So in every stoichiometry problem, we start with our given, which is 6.44 grams of sulfur. Okay. Next, we want to convert grams of sulfur into moles of sulfur. So we put that over 1. We do our conversion factor. Now grams of sulfur is on top, so we want grams of sulfur on the bottom, and we are converting that to moles of sulfur. Okay, so the number that goes next to moles is 1. The number that goes next to grams is the molar mass of sulfur, which turns out to be 32.07. Okay, so now grams of sulfur cancels out. We're left with moles of sulfur, which is not where we want to be. So we want to do another conversion factor. So since we have moles of sulfur on top, we want moles of sulfur on bottom. And we are converting to energy here, okay? So in a regular stoichiometry problem, this would be the mole-to-mole ratio. But since we're not converting to some other compound, we don't have a mole-to-mole ratio. Instead, we have a mole-to-energy ratio. So we're going to go from moles of sulfur to kilojoules. Now, the number that goes in front of moles of sulfur is the coefficient of sulfur. So that's going to be 2. The number that goes in front of kilojoules is going to be our delta H. So that's going to be negative. I didn't really leave myself enough room here, but that's okay. We can squeeze it. Negative 791.4 kilojoules. Okay. So now moles of sulfur cancels out. We are left with kilojoules, which is where we want to be because this problem is asking how much heat will be released. Heat is measured in kilojoules. So we are done with our dimensional analysis. So now we multiply all the top numbers. We get negative 5113.36. We multiply all the bottom numbers. We get 64.04. Then we take 5113.36 divided by 64.04, and we get negative 79.8. And can't forget our units, kilojoules, because kilojoules are what is left here. So this is our final answer. And that's all there is to it.